This is Lakshmi. In today's session, I am going to discuss D block elements. In this video, I am going to give some shortcuts in D block elements like short revision. Inorganic chemistry chapters, I am doing short revisions. Recently, I have uploaded chemical bonding topic 4 parts and 15, 16, 17 group also where students more confusing detailed explanation I had given. Go through it. And next in this video, I will try to complete the maximum shortcuts D block elements like a short revision. What frequently asking questions in NEET examination and mains examination. Based on that, I made some shortcuts. Please do it and try to read all the points and get good marks in your examination. First, we are going to start with the definition. What is the definition, students? I have written here to save the time. Differentiating electron enters into n-1d penultimate shell. Last electron entry into s orbital s block elements, last electron entry into p orbital p block elements, like that single definition where we have studied in S and P block elements. Main energy levels it's going. That's why those elements we call it as representative elements. But here it will be little different. Differentiating electron enters into n-1d penultimate shell. First, what is penultimate shell? Let me give some idea. See, I have taken one atom. Atom has nucleus. It has differentials. 4 differential atom I have taken. In this, the last shell we call it as outermost shell, valency shell, and one more name, ultimate shell. It is represented by the letter N. And the next, before that shell, we call it as penultimate shell. It is represented by the letter n-1d. See, students, suppose the last one value, if n equal to here 4, definitely here what is this? n-1. n-1 means you will get 3. Here like this. So suppose here 5, this is 4, this is like this. And 3 if it is not there. Okay, 6. Okay, to understand only these 2 points I am telling, n equal to 4, this is definitely it is less than 1 number. Like that you can understand. Ultimate shell, penultimate shell, anti-penultimate shell. So before that shell we call it as anti-penultimate shell. It is represented by n-2d. Okay, if n equal to, you will take 6 here 5, here 4f series. If here n equal to 7, you will take 5f series. You will get whenever f block elements, I will give the shortcut time. I will explain. Here I will come back to this one. Again, points you will see. Ultimate shell. The last shell we call it as ultimate shell, represented by the letter N. Before that, penultimate shell. Before that, we call it as anti-penultimate shell. Representation also I have given. Now, let me take one example and try to give definition meaning. Differentiating electron enters into n-1d penultimate shell. See, electronic configurations also most of the students bit confusing. So I have uploaded some 2 videos electronic configurations. Shortcuts also had explained how to write, and next one 4 different methods electronic configuration I have taught in that video, and chromium and copper up to 30 elements we have 2 exceptional cases, chromium and copper. Based on that also I have uploaded the video, so please watch it. So now this is electronic configuration of scandium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. The last electron, see, if you write shell-wise representation, most of the students confusing next part is last shell finding. Last shell is nothing but highest principal quantum number. Highest number where it is, this is 4, no? That is highest principal quantum number is last shell. If you write shell-wise representation 1, 2, 3, 4. So this is the last shell, we call it as ultimate shell. Before that shell, we call it as penultimate shell. Last electron entry into penultimate shell. So this is the definition of differentiating electron. What is this? D block elements. Differentiating electron enters into n-1d penultimate shell. So finally, what is the conclusion? The last differentiating based on electron entry only, we are dividing into blocks. The last electron here entry into D block. Finally, those are we call it as D block elements. But proper definition means penultimate shell we have to add. Now next one. Here, first I am going to write where we have to concentrate points in D block elements. So topic 1. Topic 1, electronic configurations. Electronic configurations plays important role. Next one, atomic radius. Atomic radius. Next, third one, ionization energy. So here so many questions are there, but today only few questions I am explaining. Next videos, coming videos, remaining on the parts I will complete, and previous year questions also I can start after a few days. First you learn the concept, then I will come with the previous year questions. Ionization energy, and next one is colorless. Next, paramagnetic and diamagnetic. Paramagnetic, diamagnetic. Next, sixth one, magnetic moment. Okay, now next one, catalyst. These are all properties. Next, complexes. Why transition elements forms complexes. Next one, variable oxidation states. Variable oxidation states. Next one, interfacial compounds. And today's last one is metallic bonding, intermetal melting points. Okay, now one by one we will discuss. It may be take time, 20 minutes or 25 minutes students, but definitely it is useful video for you. So electronic configuration, I said already I have uploaded video, please watch it. Electronic configurations, 2 videos, and atomic radius also 2 videos I have uploaded. Atomic radius, single word we are not using in D block elements. So whereas atomic radius, when we are studying in S and P block elements, only exceptional group is 13th group elements, aluminum and gallium case. Due to poor shielding effect of d electrons, gallium size is lesser than that of the aluminum. Only one exceptional case we are studying. Remaining all the cases S and P block elements, as we move down the group, atomic radius increases, we are learning. But D block elements, it's not single word students. We have exceptional cases. I have explained very clearly in the 2 videos, and especially lanthanide contraction 4D and 5D series, that you can watch it. Okay. Next one, ionization energy. Now, few questions I am explaining now. Before going to that, let me cover another question first. 3D series. I will write your 4D series and I will write your 5D series. 3D series, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, this is what anybody know? What is this? It starts with yttrium, next zirconium, next niobium, next molybdenum, next technetium, ruthenium, rhodium, palladium, silver, cadmium. Next, last, what is this 4D series? What is this 4D series? Starts with, yes, lanthanum, hafnium, tantalum, chromium family only you will get tungsten, opposite, rhenium, osmium, iridium, platinum, gold, mercury. This is 3D, 4D, 5D series students. Now here I am going to give some names according to old, according to new. Okay. So first let me write group numbers. This is what? It starts with the third group. Third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. This is according to new. According to olden, it seems to be little clumsy even though I am writing students. This is starts with 3B. This is 4B. This is 5B. A's are S and P block. This is B. This is 5th B. 3rd, 4th, 5th, 6th B. Then this is 7th B. Together, call it as 3 families together, we call it as 8B. Next, this is 1B, 2B. Don't write 9th B, 10th B. 1B, 2B. Okay, so this is one of the most important one. 2B separately. See, I am writing here. I am writing all important competitive points. Competitive examination, generally what they are asking questions, based on that I am giving notes to you. So go through the points. These are all you can learn. Next videos we can do the questions. Now, 12th group are 2B group. 2B group, non-transition element. Not a transition, that is nothing but non-transition element. Okay, point 1. Point 2, group third to next 11th group. 11th group called transition element. Transition element. So actually olden definition, transition elements is nothing but in between. In between is nothing but D block elements properties are belongs to both and S block. When compared to S block, less metals. When compared to P block, it is more metallic nature, like that. But the correct definition now I am going to give. Before going to the definition, students, I will give you other points. Electronic configuration. It is also plays very important role. Let me write here general electronic configuration down. General electronic configuration of D block N minus 1 D 1 to 10 NS2. This is the D block element general electronic configuration. Next, this is point 3. Point 4, see again I can show here only, I will explain the question. I'm going to round off some examples, means that is plays very important role. See, osmium ruthenium shows +8 oxidation state, +8 oxidation state. Example OSO4. Okay, down I will write all the points. Here I am showing OS4. So how to calculate oxidation state I will explain. And the next one, in 3D series, manganese shows +7 oxidation state, highest oxidation state. Next, this family, chromium, molybdenum, tungsten, more melting points. I am covering here only shortcuts, like why it is more melting points I will show. Next, 3D series, 4D series, 5D series, we call it as twins. Twins means similar properties. Here similar properties is atomic radii. I said already, so I have uploaded video atomic radius. You can watch it, you'll come to know. Similar properties, atomic radii. Twins baby means definitely they have some similarities. Here tungsten, especially tungsten, has more melting point, nearly 3200 Kelvin. Okay, zirconium and osmium, one of the frequently asking questions. Zirconium and osmium have similar atomic radii due to lanthanoid contraction. I'll write all the points now. Okay, students, now points wise I'm writing. These are all competitive questions. Osmium, ruthenium, and xenon also. It is not D block, but I am writing. Shows +8 oxidation state, highest oxidation state in periodic table. Shows +8 oxidation state in periodic table. It is the highest oxidation state. Clear? Now, example, OSO4 -8 +8, each oxygen -2, like this. Xenon, XeO4 also. This is -8 to +8. Now, next one, 0.5. 0.5, what I'm trying to say is chromium, molybdenum, tungsten have more melting points and strong metallic bonding. Due to more unpaired electrons. Clear? Now, next point. Sixth one. Manganese shows +7 oxidation state. It is highest oxidation state. It is highest oxidation state of manganese in 3D series. In 3D series, which element shows highest oxidation state? What is the element? Like that? They'll ask. What is the oxidation state? What is the element? They'll ask questions. Manganese. Next one. In 3D series, Zn. Scandium +3. Colorless. See, so I'll explain colorless and color. I will write the points, so many points it will come. Okay, better. First, let me complete the explanation part. Ionization energy. Okay, see students, ionization energy. Ionization energy means just simply I am writing what is this? Removing electron. Removing electron means required energy. Removing electron, it required energy. Required energy means it is endothermic. Briefly, I am writing definitions and all ionization energy we have studied in first year. But here, what is the important points I am writing? Removing electron means definitely it is required energy. Required means it is taking. Taking means always endothermic process. This is basic point. Second point is, so off-filled and completely filled. Off-filled and completely filled atomic orbitals are more stable. See, with strong guys fighting is difficult, right? So here also same thing. If you want to fight with the strong guy, we need more energy, right? We need more energy. Here also the stable guys are there. Removing such electrons is very difficult. If it is more stable, definitely ionization energy is required more. Okay, now I will show. Copper +1, copper +2. So in which case ionization energy is high? Ionization energy is more in which case? See, copper first electronic configuration 29. It is exceptional case. I said no. Video I have uploaded. You can watch it. 4s2 3d9 we expected, but it is wrong. No, exceptional case. What is exceptional case? This electron jumps here. One electron jumps here. Why it is jumping? because to get stability. This is 3d10 completely filled. S capacity is actually 2. Now exactly half filled. To getting more stability, one electron exchanging. Only one electron exchange is possible. More than one, it's not possible. That's why chromium and copper shows. Now copper plus 1. Copper plus 1 means where we are removing electron. Last shell. This is important. Last shell means just you can pick out highest principal quantum number 4s1. Remove electron. We are supplying energy, removing electron. That's it. After removing, what is this? This guy will go 3d10. Now copper plus 2. Copper plus 2, we are removing electron where? 3d10, completely filled. It is completely filled or else fully filled, right? So it is more stable. Completely filled, fully filled. It is more stable. So it is possible but very difficult to remove. So that's why copper plus 2 ionization energy is more exceptionally high. Like this, we'll get question. They're giving ionization energy means definitely exceptional cases, definitely half filled and completely filled electronic configurations only to give. Okay, now next one. Atomic radius irregularity is there, definitely ionization energy also irregularity will come, students. Now, next one, another important one is magnetic moment calculation. Magnetic moment. Here we have best shortcut. Magnetic moment. Bohr only had given mu equal to root over n into n plus 2. N into n plus 2 and units also Bohr magneton. Here n refers n equal to number of unpaired electrons. Number of unpaired electrons. Okay. So let me give some examples. I will explain one question, students. Remaining example you can work out. First, I am writing whatever frequently asking questions in examination. Scandium plus 3, Zn plus 2. Next one, manganese plus 2, iron plus 2, iron plus 3. Okay. Next one, cobalt plus 3, nickel plus 2, chromium plus 3. These are all cases. But don't worry, so many examples is there how to calculate. With a simple shortcut we have. So number of unpaired electrons, no. So find. First let me take ion plus 3, students. Ion plus 3. Okay, ion plus 3. First of all, you have to learn atomic numbers. 3D series, everybody must learn atomic numbers, students. So atomic numbers, electronic configuration video, you can watch it. Definitely will get good idea. This is the short revision like. Okay, Fe, ion 26. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Simple. What is the number? You can write. That's it. Simple shortcut. So what is this? Chromium, except chromium and copper, remaining all the cases, what is the number? You can write. Up to here it is common. So this is argon. This is argon. You can write argon 4s2, 3d6. So what I am doing here, ion plus 2. Ion plus 2 means where I have to remove electron? This guy. That's it. Argon 3d6. Right or not? Fe plus 2. Fe plus 3 I said no. Fe plus 3. Plus 3 means 4s2 here, 1 electron here. 1 electron here. 1 electron. After removing 1 electron, now what happened, students? Now 3d. 3d, 5. Clear what I am trying to say? Here, ion plus 3. Plus 3 means ion lost 3 electrons. Ion lost 3 electrons. Where it will lost? Systematically. Last electron to before. First electrons will come. Last electron, these two, gone. But still one more gone. Where? This shell. That's it. So now he became 3d5. 3d5. Clear, students? Now write box method. Without writing box method, don't go for this answer. 1, 2, 3, 4, 5. So n equal to 5. N equal to 5. If it is board examination, no students, you people have to explain like this. N into n plus 2 Bohr magneton. So like what is N here? 5 unpaired electrons. 5 into 5 plus 2 4 magneton. So right, root over 5 into 7, 35. Right? 35 Bohr magneton. But root 35 value how much? 5.8. Simple. How? Within 1 minute, how to give answer? Let me write C point. Reminding all the examples, we can calculate and check it. And scandium plus 3 and Zn plus 3 will get N equal to 0. You can check it, students. Okay. So I think it is more lengthy video. So after this, I am going to close this one, and next part I will do. Next video, remaining points I will explain. See, number of unpaired electrons, suppose 1. Bohr magneton 1.73. That's it. So just add 0.7, 0.8. That is our answer. N equal to 2, then it is 2.83 Bohr magneton. Clear? N equal to 3, 3.8. N equal to 4, N equal to 5. So Bohr magneton equal to 4.8 Bohr magneton. This is 5.8 Bohr magneton. Units also important. Next one more. N is same. N is same. Mu also same. Fe plus 2. Example. Fe plus 3 and manganese plus 2. Okay, students, up to here I have done. So if I'm explaining remaining parts also, it may be more lengthy. That's why immediately I can upload those points also, students. Thank you. Thanks for watching. Please subscribe our channel and inform to all your students, friends, then they will get benefit in examination. Thank you.